Hi, everybody. A function which can be put into the form y equals mx plus b, where m and b are positive or negative constants, is a linear function. A constant basically just means a number as opposed to a variable. Okay, so if we can get an equation into this form, then it is a linear function. So let's just work through some examples and then that'll all make more sense. Which of the following are linear functions? Here's just one example and then we'll do more. So the first example is y equals 18.723x minus 6. Is this a linear function? Well, to answer that, I need to know, can I get this equation into this form? And in fact, it's already pretty close to this form. We have y all by itself, and then equals some number times x. Okay, so we have all that. And then plus b. Here we have minus 6. Remember, m and b are just numbers. They can be any numbers, positive or negative. A lot of people would say that this is already in slope-intercept form. And most of the time, I would even say that this is in slope-intercept form. But if I'm being really technical about it, then instead of this plus symbol, instead of this minus symbol here, I would want to see a plus symbol. But that's okay. I can fiddle with this to actually get it to be a plus here, because I know that minus 6 is the same thing as plus negative 6. So I can rewrite this entire equation as y equals 18.723x plus negative 6. And then I can see more clearly that this equation is actually in slope-intercept form, and 18.723 would be my m, and negative 6 would be my b. Okay, so if I can fiddle around with this equation to get it into perfect slope-intercept form, it means that my original equation is a linear function. Okay, let's move on to and also I want to change my color here, just a brighter color now. What about this over here? 2y minus 4x is equal to 8. Well, it doesn't look like this equation is, it doesn't look like this looks anything at all like this, right? I have some coefficient in front of the y here. I have x and y both on the same side of the equal sign. They're both on the left here, whereas in here I had the y on the left of the equal sign and the x was on the right side. So it doesn't look like this equation is in slope-intercept form, and it's not in slope-intercept form right now. But the question is, can I fiddle around with it and get it into slope-intercept form? Let's try. So in order to do that, what our goal is here is to get the y by itself, okay? And then we'll be able to see if it is or is not a linear function. So how would I get the y by itself here? Well, I'm going to want to get rid of this minus 4x. So what could I do? I could add 4x to both sides. Well, I can't add an x term to this 8 over here, so I'll just have to put it next to it. So that would cancel, and I get 2y equals 8 plus 4x. Remember, I didn't say 12x, like 8 plus 4 is 12, because this has an x in it, this does not. And then I'm almost there. I just want to get the y by itself. Now it has a 2 in front of it, but what I could do is I could divide by 2 and then divide the other side. Remember, if I multiply or divide, then I have to do it to every single term. So I will divide both of these terms by 2. So 8 divided by 2 is 4, and 4 divided by 2 is 2. So I'm going to get 4 plus 2x over here. And now we can see that it is in, well, I guess if you really, it's still not exactly looking like this, but that's just trivial here because the commutative property 4 plus 2x is the same as 2x plus 4. So if I really want to write it like that, then I could just flip those around. That's no problem. So yeah, so I can fiddle around with this equation to get it into the form of y equals mx plus b, where I see that here my m is 2 and my b is 4. So that's fine, and it means that this equation and also this original equation represent a linear function. And remember, a linear function, if we were to plot it, is a straight line. And if you're really perceptive, you might have noticed that this equation that I just gave you is exactly the same equation that we were looking at in the last video, that 2y minus 4x equals 8. And what happened when we plotted the solutions to that equation? We got a straight line. So if I can fiddle around with an equation and get it into this what's called slope-intercept form, and I'll explain in another video why it's called slope-intercept form. But if I can fiddle around with an equation and get it into this form here, then I know that it must be a linear function, which means that when I plot it on a graph, I'll get a straight line. Okay? Let's move on to the next example, which is this over here. And you can see that this x term over here is being squared. And there's really nothing that I can do to get this into this slope-intercept form, y equals mx plus b. I could try to get rid of that exponent by, let's say, taking the square root. So maybe I could subtract 1 from both sides. And I can't really subtract 1 from a y term, but I can sort of put it on the side here. So I could get -1 plus y equals x squared. And then to get rid of that exponent of 2, what I could do is I could take the square root of both sides here, and that would cancel that out. So I would have x. So now I got the x without the exponent. But then look what I did. I completely messed up the y. Now it's trapped under this square root sign. Okay, so yeah, so that, and so there's really nothing that I could do to get rid of this exponent without messing the y up even more. So I can't fiddle around with this and get it into this form. And this would be an example of a function which is not linear. And if you're perceptive again, you might notice that this equation is the other equation that we had in the last video, y equals x squared plus 1. And you can see that when we graphed the solutions to that equation, we didn't get a straight line. We got a parabola over here. So we couldn't get it into this form. And just like I promised you, if we couldn't get it into that form, it means that it is not a linear function. Okay, we did not get a straight line there. Now, what about the next example over here? We have -x, or the opposite of x, minus 70 is equal to 7y. Can I fiddle around with this? Well, let's see. I could try to get, it looks like the y is already almost by itself. Remember, we want the y to be by itself. What I could do here is I could divide this by 7, and then I would have to do the same thing to the other side. So I would get y equals, so this is like -1 times x. So this would be -1 over 7, or -1/7 x. And then this minus 70, and then I divide that by 7, I would get -10. Okay, now it looks like this is in this form. You might be bothered by the fact that the y is on the right side, but that doesn't really matter. If you want, you could write the y on the left side just to make it look even closer to this. So y equals, then we'll just put all this on the right side. It doesn't matter what side it's on. So we'll just move all this to the right and this to the left. We get y equals -1/7 x minus 10. So the fact that this is a fraction and it's also a negative number does not matter. So our m is simply -1/7. It might look messy, but it's okay. It's a perfectly fine constant for our m value. And actually, what I could do is like what I did in the first equation. I could rewrite this, instead of -10, I could rewrite it as plus negative 10, because plus negative 10 means the same thing as minus 10. And you can see that my b value is negative 10. So this is perfectly fine. It's okay to have fractions. It's okay to have decimals. It's okay to have negative numbers. And this is in perfect slope-intercept form, which I'll talk about in another video. And this would also be an example of a linear function. So if we were to find solutions to this equation and plot them all on a graph, we would see that those solutions would be making a straight line on the graph. For the next example here, let's look at -1 minus 70x equals 7xy. Okay, so what we're going to do is try to get the y by itself and then see if the other side is in this form. So in order to get the y by itself, I would have to get rid of this 7x that's right next to it, which is being multiplied by the y right now. So to get rid of that, I would have to divide both sides by 7x. Now, you have to be careful when you divide by a variable, because if there's a possibility that the variable is 0, then you're not allowed to divide by 0. But I'm just going to sidestep that little issue right now and just ignore that, and we'll just say it's okay. So over here, I have y equals, on this side, I would get -1 over 7x, which would give me just -1 over 7x minus, and then 70x minus divided by 7x would be 1. Again, assuming that x is not 0, and then I would get 0 over 0, and that would be all sorts of problems. But over here also, assuming that x is not 0, let's just ignore that. And when we divide both sides by 7x, we get -1 over 7x minus 1 is equal to y. What if I tried doing what I did before, and then let's just put the y on the left side, just to make it look a little bit more like this, equals -1 over 7x minus 1. So this might look very similar to what we had in the last equation, but there's a key difference here, and that is that here the x is in the denominator. So it's all right to have a fraction multiplied with the x, but that's not what this is. This is not a fraction being multiplied by x. This is a fraction with x in the denominator, which is actually equivalent to this. Actually, -1 over 7x is the same thing as -1/7 divided by x. So instead of having -1/7 times x like we had in the last example, if you want to rewind the video and go back there, now we have -1/7 divided by x. That's what this is equivalent to. And that's no good. That's not a linear function. And there's no way that we could fiddle with this anymore to get it to be into this form that we want, which is some number times x instead of some number divided by x. So now would be a good time for me to scroll down a little bit. Maybe I should have done this earlier. After getting y by itself, we don't want to see exponents. That's why I said maybe I should have done this earlier, because in this example where we had an exponent, it turned out that there was no way to get this back into this form. So we don't want to see exponents in our equation. If we see exponents like this, then right off the bat, we know it cannot be a linear function. But also, we do not want to see x in the denominator like we did over here. So if we see exponents, or we see that the x is in the denominator, then no good, not a linear function. All right, we're going to do one more example here. That's for the next video. All right, 3/11x equals y over 5 plus 8. Can we fiddle with this to get it into this form where y is by itself and we see some number being multiplied by x plus another number? So over here, the y is not by itself yet. I have a 5 here, I have an 8 here. So what I'm going to do is I'm going to take away this 8. So let's subtract 8. That was plus 8. The inverse of addition is subtraction. So to get rid of it, I'll subtract 8. I have to do the same thing on the other side. This is an x term, but this is not. So I can't combine this and this. So I'm just going to have to put the minus 8 sort of on the side there. And this would cancel. I would get negative 8 plus 3/11 x equals y over 5. And then the last thing that I need to do, since this y is being divided by 5, to get rid of that 5, I would have to multiply both sides by 5. Remember, anytime you multiply, you have to do it to every single term. So I'll put this in parentheses. I'm sort of running out of space here. You know what? I could just put it over here. Right? Usually you put it in the front, but you could also put it after the parentheses. It means the same thing. So this 5 times negative 8 is negative 40, and 5 times 3/11 would be 15/11 x. Okay, there's the x equals, and that canceled. That was the whole point of doing that. Equals y, and then if you want, you could just put it the y on the left side. So y equals negative 40 plus 15/11 x. And really, I already have this in slope-intercept form, but if you want it looking exactly like it is here, just because the x term is first here, we could do that over here also. It really doesn't matter, but just to make it look exactly like this, since this is addition here, the commutative property says I can flip these two around. So this is the same as 15/11 x plus negative 40. Yeah, let's just write it that way, plus negative 40. So you can see that I did get it into this form where the y is by itself, and I have some number times x. So my m would be 15/11. That would be my m, plus some other number. So my b here would be negative 40. So this actually is a linear function. And you know what? Let me go back and just put a check mark next to all the linear functions, because I realized I didn't do that, even though I said it. So this would be a linear function. That's fine. Which other ones would be a linear function? This one over here was not a linear function. If you don't remember why, then just rewind the video. This one over here was a linear function. That was good. Again, if you don't remember why, then just rewind. So that one was good. That was a linear function. What about this one? This one had an exponent. This one is not a linear function. And this one was a linear function. And this one also was a linear function, okay? Just in case you missed it when I said it, if I spoke too fast, now you have all the checks and x's there. And remember, what a linear function means if we were to take the solutions to these equations here and plot them on a graph, for all the ones that I put a check next to, all of the linear functions, we would get a straight line. It doesn't have to be moving up. It might be a straight line moving down, or it might be horizontal, but nevertheless, we would get a straight line, whereas all of those other functions, we would get something which is not a straight line. Not necessarily a parabola, but just not, but definitely not a straight line, okay? So that's it. Have a great day.